This third video will now engage with what we regard as the imperative and the implications of AI for the future of learning. We do think, or do believe, that what's coming our way as a consequence of these new tools and the affordances that the AI has made available to instructors and to learners is going to dramatically impact on the ecosystems of teaching and learning in really powerful ways.
And look, you know, one of our themes is these are tempestuous times. These are very disruptive technologies. Maybe K-12 schooling won't be hugely disrupted because somebody has to look after the children, but certainly post-compulsory education, college education, university education is going to be very much disrupted by these changes. And look, K-12 education will get disrupted as well. So these are, it's kind of essential that we think about these issues as educators. So as we now go into this third and concluding video of this series, we're going to start with a provocative statement. Artificial intelligence may well be a terrible idea. Here's the man who invented the idea, John McCarthy. We want to propose something different, and we want to go back to a different intellectual tradition, which is the one founded by Norbert Wiener. Here he is. He was an MIT professor. Here he is smoking a cigar in the lecture theatre, as professors would have done back then, I suppose. And he created this idea called cybernetics. And he got the idea from the Greek word cybernetes. So the cybernetes in this vase, this is the Odyssey, and there's poor old Odysseus up there tied up against the mast, and the sirens tempting him. Anyhow, they're rowing along, and the oars person at the back was called the kybernetes. And what the oars person did is they pulled the oar one way, then the other, then the other. They were constantly adjusting what they were doing. Even to go in a straight line, they were constantly adjusting what they were doing. So the cyber idea is actually the idea of feedback. So compared to artificial intelligence then, a cyber system is a feedback system. So artificial intelligence assumes here we've got a human being and here we've got a machine, and the machine can replicate what humans do. There's intelligence one, and here's a replicant of it over here. Well, our argument is these are fundamentally different kinds of intelligence, and that what is most interesting and most profound is the possible relationship between two very, very different kinds of intelligence and the feedback systems between those kinds of intelligence. Now, we hear a lot of talk today about, artificial and general intelligence. Will it come next year or the year after? Or has it come already? An artificial superintelligence, which is far more than humans. So general intelligence, by the way, is the G of intelligence tests. That's what we always measured when we measured intelligence in schools. But superintelligence is when these things have gone way beyond that threshold and they're much smarter than human beings. So here we have Alan Turing's first computer, the Manchester 1, back in the late 1940s. And one of the things that machine can do from the very beginning, which was more than humans could do, was discover impossibly large prime numbers. Now, only a machine could do that. So one of our arguments is that in their own peculiar ways, computing machines have always been much smarter than humans in some respects. And they get much smarter than humans in many, many respects as time goes on, but in very, very different ways. So our argument is artificial and general intelligence is kind of a nonsense concept. If they keep talking about that, it's trying to, think that the machine is doing what humans do. It always did more, and it can never do the same. This then is our kind of model of what's happening in today's artificial intelligence. And what we want to say, look, in fact, it's in a number of senses, it's collective and not artificial intelligence. So what we've got on the left is we've got machines that can do a lot of internal processing. These are learning machines. That was our basic premise right from the start. They can absorb stuff and they can learn things in their own peculiar ways. And on the right, we've got human learning, where yes, we can reflect on things and we can, there can be cycles of learning. But what we can also do is we can involve machines in that process, have a relationship between these two types of machines. Now, in what sense, and this is the point where I might start agreeing with Mary from going back to slide number 1. video number one, I mean, is that in fact what we've got is humans are heavily involved in this cyber-social learning relationship right from the start. So firstly, the LLM corpus is everything that's been published and, you know, the morphemes that are out there. That's very, very human. And that what we've got is we then put that into a training mechanism where we have reinforcement learning, a very kind of human kind of idea, where it learns about the relationship between tokens, and which are a series of these statistical vectors or these vectors about probability. It learns from that original source because it's actually been programmed by this idea of reinforcement learning, again by humans. Then what we do is we fine-tune the thing, so it doesn't give you answers that are inappropriate. It doesn't tell you how to create a dirty bomb for the purposes of terrorism. It might be able to do that, but in fact that's all been tuned out of it. So that's the next thing we do, the fine-tuning process. Then there are meta prompts, which actually tell the LLM how to speak when you put in a prompt. Then there's the user prompt. The thing's totally dead, does nothing, says nothing, is inert until somebody puts in a prompt and says, tell me about whatever. Well, it's prompted by a human being, and then beyond that, today's LLMs also have these reasoning processes where they go back and they don't just give you a direct answer. They go through a number of steps before they do that, and they've all been pretty well manually programmed by human beings. So what we're saying here is that we have this machine which is deeply, deeply human in its sources and its operation, and then when we as humans interact with it, it's in this larger cyber-social learning context. A concluding slide then. Human and machine intelligence are so different that it's even a problematic thing to give the things the same name. Is it intelligence? Well, it's certainly not a replicant of human intelligence, but even calling it intelligence, well, it's just something else. And look, let me just say a couple of things about the profound differences. Remember back in video one, we said, look, this is just a machine that deals in binary notation. And it only can deal in zeros and ones. And the brain is much more than binary. I know people try to use brain metaphors all the time, neural nets, and the idea that nerves are on and off. No, brains are much more than that. Secondly, bodies are much more than brains. We smell things, we feel things, we sense things, we have instincts for things, we laugh and we cry, we do a whole lot of things which are much more than purely cognitive. And the third thing is meanings are in contexts. I might write something down, but when I'm in the kitchen, and I might get burnt if I do this, and I walk around and something's placed somewhere else and someone's placed here. The meaning is actually not just in our brain and our bodies, but in the world that surrounds us, the environment that surrounds us.
We started off by saying that we're living in a disruptive moment, and that's certainly true, I think. And the main cause of this disruption, of course, is this thing that we call AI, or artificial intelligence. And its power, I think, can be recognised by the fact that it's valued in the trillions of dollars. I mean, it's just amazing that, half a dozen large language models are attracting investors of the size and the value of the size that is growing by the day. It does mean that society thinks they matter in some powerful way, but there's nothing definitive for educators at the moment as we experiment with what to do with AI in the classroom, or even for our personal use. It's a tricky moment, and even as we try to understand it ourselves, even as we try to harness it for particular purposes, and have shown you an example with some elements about what we think would be a more creative way of using it, it's changing by the moment, and what it can do and can't do is also changing by the moment. So I think we have to be mindful of that. So the final thing I want to say is, as educators, we need to be very flexible at the moment as we experiment with what's possible and analyse and think about what we can do in this disruptive moment. But that requires us to have repertoires the traditional ways in which we taught and which we learned are becoming unstuck in some ways or being restuck on other things. So we need to be able to pick and choose what's appropriate for individual students or programs. So expanding our repertoire matters. But finally, and we want to end on this note, we have to collaborate. It's impossible for us now as individual educators to resolve this disruptive moment without collaborating with others, whether it's changing the spaces in which we work, creating the new ecosystems, judging the kinds of tools we can use and for what purposes. This is not a moment for individuals and individual classrooms. We need to go beyond that now if we are to genuinely harness AI and to make it work for teaching and learning into the future.